Hello students, you are watching crystal field theory topic, crystal field theory continuation. So in the previous video, I have explained about splitting of d orbitals in octahedral system. Let us do a quick recap of the topic. I said d orbitals are degenerated when the metal atom is alone, and when the ligands approach the metal atom in a symmetrical manner, there exist repulsions between the electrons of metal and ligand, so that the degeneracy, the electrons will go to higher energy levels. Then in octahedral system, ligands approach the metal along the axis. Listen to my point, it's a very important word. Ligands approach along the axis. That's why the d orbitals which locate along the axis, that is a Eg orbital, will go to higher energy level, and T2g orbital will come down to lower energy level. And the energy gap between these two is called as crystal field splitting energy. Symbol is del O. That is what we have studied in the previous topic. So today I'm going to explain the continuation of that. Here the crystal field splitting energy depends on two factors. Depends on, first point, it is central metal d orbital electronic configuration of central metal, means d1 system or d2 system, d3, etc. That is what we have seen in the previous case. In the previous video I have explained that in detail, so in case if you have not watched that, just please go through the playlist and you will get that one. Second one, this depends on the nature of ligand also. So nature of ligand also create impact. So how we can say that nature of ligand will create impact? Ligands are classified into two types. So based on the crystal field splitting energy, based on CFSE, crystal field splitting energy, we arrange, it's an experimental value. Ligands are arranged in a series manner, arranged in a series, which is called as, that series is called as spectrochemical series. Right, a spectrochemical series. Many students, they ask what is spectrochemical series. So it is the arrangement of ligands in the increasing or decreasing order of their CFSE value. So if you take some ligand ammonia, CFSE value will be different. If you take a chloride, CFSE will be different. So based on that we arrange them. That is called as crystal field splitting spectrochemical series. The spectrochemical series is I minus is a weakest ligand, then Br minus, then it's NCRT one, thiocyanate, SCN minus, then Cl minus, chloride ion, then sulfide ion, then fluoride ion, then hydroxide ion, then water, oxalate will come before to that, oxalate, then water, then isothiocyanate, then EDTA, EDTA 4 minus, then ammonia, then ethane 1,2 diamine, then CN minus, and carbon monoxide. This is called a spectrochemical series. Now I am going to explain you very beautiful technique to remember this. Very important and very easy technique. So many students ask, sir, how to remember this one? So there is a simple line you can remember. I brought sweets, you can say, you can say instead of sweet I can say some stands for thiocyanate, some colorful sweets from office from office containing water. Now here it is some student name or some person name, Nancy 8 4, you can say that 8 9 instead of 4 9, among them 9 in canteen corridor. This is a very easy thing to remember. So I brought some colorful sweets from office containing water. Nancy ate 9 of them, you can say 9 in canteen corridor. I brought means bromide ion, some means thiocyanate, colorful chloride, sweets S2 minus from F minus, office OH minus, containing oxalate C2O4 2 minus, water H2O. Nancy NCS minus, 8 EDTA. And 9 stands for ammonia, in means En, ethane 1,2-diamine, canteen means Cn minus, corridor is carbon monoxide. So here the ligands which come after water, like these all NCS minus EDTA, they are called strong ligand. Especially these four are called as strong field ligands, and the remaining all other are called as weak field ligands. Understood this spectrochemical series? I think you can remember it now easily. Now this is the NCERT spectrochemical series. This is what I am telling you. It is a spectrochemical series given in NCERT, but we can add few more in between that will be useful. After ammonia it comes pyridine, which comes in between to ammonia and En, and En after NO2 minus, nitrite ion will come, then after CH3, then Cn minus. Clear? So I repeat once again, I'll write also, have a look at this all. Yeah, I repeat that what you have to remember. I brought, you have to remember this, I brought some colorful sweets from office, containing water. Now Nancy ate 9 of them in canteen corridor. So that is the simple equation. Here you will get I minus, it is a weakest ligand, bromide Br minus, some means thiocyanate, colorful means chloride ion, sweets means sulfide ion, from means F minus ion, office means OH minus, containing it is oxalate ion C2O4 2 minus, water it is H2O. Nancy means isothiocyanate, 8 means EDTA, 8 means EDTA 4 minus, then 9 means ammonia, then En means ethane 1,2-diamine, canteen means Cn minus, corridor means CO. This is the easiest technique to remember spectrochemical series. Got it? Now you can also remember like this, what is a strong ligand and weak ligand. Strong ligands are those having donor site. The donor site of strong ligand is either carbon or phosphorus. The strong donor site is either carbon, you can see the donor site is carbon, and here donor site is carbon, and in EDTA you can see even nitrogen also. In EDTA the donor site is nitrogen, in ammonia donor site is nitrogen. So this strong ligand, if the donor site is either carbon or phosphorus or nitrogen, then it is a strong ligand. Example, you can say Cn minus, CO, then NH3, then En. Weak ligands. Weak ligands are those ligands where the donor site is electronegative atom. Electronegative atom like halogen or sulfur or oxygen, like all halide ions, chloride, fluoride, bromide, they all are weak ligands. Then S2 minus, then SCN minus, where sulfur is a donor site, or OH minus, or in oxalate C2O42 minus, they're also donor site. What is the donor site in oxalate ion? That is oxygen. This is oxalate ion structure. So in this way, weak ligand and strong ligand can easily remembered. So this is all about splitting of d orbitals in which system? Octahedral system over. Now we will see splitting of d orbitals in tetrahedral system. Splitting of d orbitals in tetrahedral system. Yes, first of all, in tetrahedral you have to see how ligands are approaching the metal. So if you take a metal here in tetrahedral system, the angle is 109 degrees. So point number 1, there are only 2 points here. Ligands approach the metal in which way? Think about it. Approach the metal in between to the axis. In between the axis. Previous time they came along the axis. Now in between the axis. Suppose if you see, this is x-axis, this is a y-axis, this is z-axis. So ligands are approaching in between the axis. So that's why in metal, which d orbital will experience more repulsions? Since they are approaching in between the axis, so T2G orbitals where lobes present between the axis, experience more repulsions. Got it? So T2G will experience more repulsion and EG will experience less repulsions. So which is opposite to the previous case. Okay, so now how can we show the splitting diagram? This is d orbitals arrangement when metal atom is alone. All the d orbitals are degenerated. Now the ligands are approaching the metal in a symmetrical manner. Ligands are approaching the metal in symmetrical manner. So there exist repulsions between electrons of metal and electrons of ligand. There exist repulsions. So the d orbitals will go to higher energy level because of the repulsions between electrons of metal and ligand. Now ligands are approaching in which way? Let us say these are the axes. This is x-axis, y-axis and z-axis. So here one ligand is coming in between the axis, the other ligand is coming in between the axis, third ligand is coming in between the axis, and fourth one is also coming in between the axis. So ligands are coming in between the axis, so that's why T2G will experience more repulsions because in that also the lobes are present in between the axis, and EG will experience minimum repulsions. EG. And now the energy gap between these two is called as crystal field splitting energy for tetrahedral system. Symbol is del T. Last time we wrote del O, that was for octahedral and it's for tetrahedral system. And this is a barycenter. The energy of T2G is increased by, of course, 0.4 del T. It is increased. and it is decreased by minus 0.6 del T. Now what can be the formula for crystal field splitting energy here? CFSE del T is equal to, what formula you can write? 0.4 into number of T2G electrons, correct, number of T2G electrons, minus 0.6 into EG electrons, and of course plus pairing energy. This is the formula to calculate splitting energy in the case of tetrahedral system. Understood this one? Yes, take a note. Now comparing del T means splitting energy for tetrahedral and splitting energy for octahedral system. Suppose there is a complex d orbital. Let us say if it is forming octahedral system, this side I am writing octahedral system. In octahedral system there will be 6 ligands. Keep it in mind. There will be 6 ligands which approach along the axis. So which one will go upside and which one will come downside? EG will go upside. EG will go upside and T2G energy will be decreased downside. Right. So this is, you can say, they split in this way. This is octahedral system. If the same compound, if it form tetrahedral complex with 4 ligands, just 4 ligands, so here number of ligands are decreased, so repulsions will decrease. So repulsions will decrease means the energy gap will also decrease. So you see the energy gap is decreased. This is del T. The energy gap is del T and this energy gap is del O. So which one is high and which one is less, that you have to see. So this is a del T value. This is the del O value, and from this it is very clear del O is greater than del T, because here 6 ligands are coming, so there will create more repulsions, whereas 4 ligands are here which will create less repulsions. There is a relation between del O and del T. So del T is equal to 4 by 9 times of del O. It is an experimental value, so you can just remember this. This is del T and del O. Here this is all about tetrahedral system classification. Now one important question is there based on NCERT. The question asked like this: why low spin complexes means against to Hund's rule. Against to Hund's rule, that we have to understand, they don't give. Against to Hund's rule is rare for tetrahedral system. Why low spin complexes are very rare for tetrahedral system? That is a question asked in NCERT. You can see very well. So when the low spin complex will generate the electron if it pair here against to Hund's rule. So why against to Hund's rule is rare? You can see the energy gap is very less. So if I say first electron goes here, second electron will go. Since the energy gap is very less, the third electron will automatically go to next level. So that means pairing will not be done in against to Hund's rule. So that I can explain. So here, since del T is less than del O, so the energy gap is less, so pairing of electrons is always done according to Hund's rule. Is always done according to Hund's rule, which results in which one? high spin complex. When electrons are paired against according to Hund's rule, so high spin complex will be formed. So energy gap is important. Got this point? So note down this one. It is splitting of d orbitals in tetrahedral. Now splitting of d orbitals, little bit extra point. It's not in NCERT. Splitting of d orbitals in square planar system. In square planar system. So it is not in NCERT, but it is asked in 1 or 2 times. IIT JW Advanced, they have asked for 1 time. So when square planar system will come, when square planar system will be observed, when we have dsp2 hybridization, right? Here the d orbital is which one? It is a dx square minus y square is that d orbital, which means here 4 ligands will be there in square planar. 4 ligands approach along x-axis and y-axis. So here approach is very important, as I always write. The ligands approach along x, y axis. Due to this, what will happen? So due to this, because of this, dx square y square, where the dumbbell is along the axis, experience more repulsion. Got my point? So that is what you have to understand. So if you understand this much, then the splitting will be easy. So I will explain the figures. So this is a metal, and all its d orbitals are degenerated and ligands are approaching in a symmetrical manner. So their energy will be increased. Now square planar system is coming. Square planar system. So here along the axis, so dx square minus y square, and the bottom here it is dxy, dyz and dzx. So I'll just label it. It is dx square y square and dz square, dxy, dyz, dzx. But what you have seen here, ligands are coming along the x and y axis. That's why which one will experience more repulsion? Dx square y square will experience still more repulsion. So that's why here it is a dx square y square. As well, this dxy also little bit experience more repulsions. So this is a dxy, and dz square will experience little less repulsions because it is along z axis. Dz square is on z axis and ligands are coming along xy axis, so repulsion will be less. And this one, the remaining two, that is a dyz and dzx. So this is the energy order of d orbitals in square planar system. So you have to write the energy order. So let us write MCQ. It is asked that one only. Energy order in square planar system. Energy order in square planar system. What is that? Dx x square y square will be having the very high energy, then dxy, then dz square, then dyz is equal to dzx. Clear? This is the MCQ question and important question. Right. So note down this. Now last one, it is a splitting of d orbitals in trigonal bipyramidal system. Trigonal bipyramidal system. Yes, how d orbitals will be splitted in trigonal bipyramidal. So in trigonal bipyramidal, what is the hybridization? The hybridization is dsp3 or sp3, and the d orbital involved here, it is dz square. Got it? So which means here 2 points. One is ligands approach along axis, but more number of ligands are coming, or you can say approach along z axis, approach along z axis. That is the point number 1. So that's why what happened, since ligands are coming along z axis, so dz square of metal, experience more repulsions. So this is the key point, will experience more repulsions. So based on that, you can write a splitting. So here d orbitals, when the metal is alone, they are degenerated. When metal is approaching when ligands are approaching metal, their energy increases because of the repulsions between the electrons of metal and electrons of ligand. Now they are coming in a trigonal bipyramidal. This is a trigonal bipyramidal structure. So ligands are coming along z axis and some ligands are coming along the axis. Keep it in mind, some ligands are coming along the axis. So as usual, first dx square y square and dz square will go upside, and dxy, dyz and dzx will come down the energy. dz square, dx square y square, then dxy, dyz and dzx. Now further splitting will happen. dz square energy will increase because dz square will experience more repulsions. So that's why I said dz square of metal experience more repulsions, and dx square minus y square will experience but little less repulsions. It will come here, dx square y square, as well as dxy also. That is a dxy, both will experience same. Then next one, it is, what are the left orbitals? dyz and dzx. Got it? Ligands are here, you see, this is coming along x-axis, this is coming along y-axis, these two are coming along z-axis. So dz square will experience more repulsions, and dx square y square also experience repulsions but little bit less. That's why it is coming down. So the energy order of d orbitals, is dz square, which is very greater than dx square y square is equal to dxy, then dyz is equal to dzx. This is splitting of d orbitals in trigonal bipyramidal stress system. So I hope you understood this one. In case if you have not understood, watch the video one more time. If you have doubt, comment in the box and I'll make video once again. Right? Thank you guys.
Subscribe now and press the bell icon. Never miss an update. Subscribe now and press the bell icon.